Okay, hi everyone. So in this video, we're going to continue with speeds, but on the idea of average speed. So as mentioned in a previous concept, right? So the average speed is something like a speed, right? The formula can be given as distance over time as well. But in this case, it is the average speed across the entire journey. So we are looking at the distance would be the total distance, right? And the time would be the total time. And this time includes the break time, right? So over here we have a generic formula for average speed, which is the total distance divided by the total time. So with this, let's take a look at the very first example. Okay, so let's take a look at practice now 18 in page 66. So the question says that in a triathlon, so triathlon means that it's an event with three different sports. So Raju swims a distance of 1.5 kilometers and they give the speed. He cycles 40 kilometers in that amount of hours, and he runs at an average speed of 9 kilometers per hour for 1 hours. So we need to look for the average speed for the entire competition. Right? So with this, let's take a look at the very basic formula over here, which is speed. Right? So we have this triangle, and we can uh, use it like this, right? So the speed equals distance over time, so DST triangle. Okay, so we can chop up this whole event into three portions over here, right? So the first portion is the swimming. So we have 1.5 kilometers, right? And we have an average speed of 2.5 kilometers per hour, right? So what is missing over here is we have a distance, we have a speed. What is missing is the time. So later we're going to look for the time over here. Now next, so this is the cycling bit, right? The next one, it is this is the first one is the swimming bit. Now the second one is the cycling bit over here. So for the cycling, we have a 40 km, right? And then we have a 1.5 hours, right? So what is missing over here would be the speed instead. Okay, and the speed is missing, and we have the very last event of running. I think it's running. So the last part is a marathon, right? Okay, so over here we have we have the speed 9 kilometers per hour, and the time is 1 and 1/9 hours. Okay, let me write like this, hours, right? So let's take a look at the missing components for each part. So for swimming, we need to look for the time. So the time for swimming, right? So let's take a look at the formula over here. So if we are looking for time, we just need to cover the time, and it will be distance over speed. So over here we have a distance 1.5 km divided by the speed 2.5 kilometers per hour. So the time would be 0.6 hours. Okay, next for cycling, okay, let's fill in the blank over here, 0.6 hours. Now next for cycling, we are missing the speed, right? So the speed for cycling, if we were to refer to the triangle, if we just need to cover the speed, and the cycling would be distance over time. So distance is 40 kilometers. The time taken is 1.5 hours. Right? So over here we have something like actually we don't need to look for this. Yeah, this one we can skip, because actually we don't need the speed for the last part. Now for the running, okay, sorry, so I think this one we just cancel, we don't need this, right? Because later at the last part we don't need the speed anyway. So for the running bit, okay, so let me delete this. Right, so for the running bit we are missing the distance. So the distance for running, so if you look at the triangle over here, distance is equals to speed times time, right? So the thing is, speed would be 9 kilometers per hour times 1 hours, right? So if you were to multiply this together with your calculator, it will give you 8 km over here. Okay, so this is the... Okay, apologies, this should be 10 km over here. Okay, so let me add this in, 10 km. So now the thing about average speed is, okay, so the average speed would be total distance over total time. So what is the total distance? We have a 1.5 kilometers from swimming, and then we have another 40 km from cycling, and a 10 km from running. Okay, and then the total time taken would be 0.6 hours for swimming, plus 1.5 hours for cycling, and 1 hours for the running. So take note that all of this must be in the same unit. So we have all the kilometers and all the hours below. So we have, if I were to put this in my calculator, okay, so we have a 16.038, so 16.038 kilometers per hour. Round this off to 3 significant figures would give me something like this, 3 SF. Okay, so this is how we calculate average speed, by considering the total distance over the total time. Okay, and in this second concept in this video, we're going to look at another application of speed when it comes to rates, and when it comes to revolving and circulating. Okay, so the thing about this next example is we're going to talk about the rate of revolution. So how much does it spin per unit time, right? So instead of a speed in a linear fashion, we are going to look at the rate of revolution. And here I'm going to give you two formulas over here. So the rate of revolutions, so revolution means the rotation, right, is equals to the number of revolutions, right, per unit time. So the thing about rate is usually in amounts over time, right? So the rate of revolution can be given as the amount of revolution divided by the time, right? And just nice, so we have one version of this. The other version of this is, if you were to look for the number of revolutions, it will be the distance traveled, okay, as it revolves, right, as it revolves, and I can divide this by the circumference of the circle. Okay, so this is the total distance divided by the circumference, so meaning the distance for each rotation. Okay, so over here I have two formulas to help you, and let us take a look at practice now 19, page 67. Okay, so the diameter of a wheel of a truck is 0.75 meters. If the truck travels at an average speed of 14 meters per second, find the number of revolutions made by the wheel per minute. So we're looking for the number of revolutions and per minute. So let's take a look at per minute, right? Giving your answer correct to the nearest whole number. So over here, the formula on the left is rate of revolution is equals to number of revolution over time, or we can make use of the distance traveled over circumference. So over here, okay, we have a diameter of a wheel of a truck, so that's the diameter, and the truck travels over here, and we are going to look at the revolution per minute. So let us calculate the distance traveled for 1 minute over here. And before that, let's do the circumference of this circle, right? So the circumference, C, is equals to, based on your primary school formula, 2 pi r, or it can be pi over pi times d, right? Because 2r is equals to 1 diameter. right? So let's take a look at the pi d over here. So this would be pi, I'm going to use the calculator version of pi, multiplied by the diameter, so 0.75 meters. So I'm not going to like get the value first. I'm going to use the pi over here in my middle step first. So I have a 0.75 worth of pi of circumference, right? So let's take a look at the distance traveled. So distance traveled by the wheel, okay, if we were to look at the speed time triangle, so we have speed, time, and distance over here. So the distance will be given as speed times time. So we have 14 meters per second times 1 minute, right? Because we want the number of revolution for 1 minute. So let's take a look at 14 meters per second. Change this to seconds so that we can match up the units and we can do the necessary calculation. So over here we have 640 meters, right? So last but not least, the number of revolutions, right, will be equals to the distance traveled, which is 640 meters, divided by 0.75 pi worth of meters. So if you put this in your calculator, you should get 356.507 revs. So this is the number of revs. So if you were to convert this to 3SF, so this will be 357 revolution. Means it will spin and rotate 357 full circles per minute. And usually revs per minute, revolution per minute, we can usually say it is, we can usually write RPM. Okay, so the unit that we usually use is RPM, how many rotations per minute or how many revolutions per minute. Alright, so at the end of this video, I want you to understand that we covered the idea of average speed, and we also covered the idea of revolution. So how fast does it spin? And over here we need to make use of the number of revolution over time, or we need to make use of the number of revolution is the distance traveled divided by the circumference. So this ends the video for average speed and the rate of revolution.